Hi everyone, welcome to today's lesson. The learning target is I can determine if the limit of a sequence is infinite or finite. Please take a look at the do now, evaluate the following limits. So take a moment right now and pause the video to answer questions 1 to 3. So if you notice for number 1, the limit as x approaches infinity, that the degree of the numerator and the degree of the denominator are the same. So the limit is the ratio of the coefficients, 4/3. For number 2, the limit as x approaches infinity, notice the degree of the denominator and the degree of the numerator. The top degree is less than the bottom degree, so therefore it is bottom heavy and it approaches 0. And then for number 3, the limit as x approaches infinity, the top degree is 4, the bottom degree is 3, so it's top heavy. However, there is a negative, so it is going to be negative infinity, or remember, it does not exist. Now remember last year in Algebra 2 you learned sequences, so today we're going to find the limit of sequences. So let's look. Let a of n be a sequence of real numbers and consider the limit as n approaches infinity of a sub n. If the limit is a finite number L, the sequence converges, and L is the limit of the sequence. However, if the limit is infinite or does not exist, the sequence is going to diverge. Let's take a look at what converges and diverges means based on a graph. So here's an example. Notice here I have 1 over x. It's diverging because it's going off to infinity, whereas 1 over x squared is converging. It converges to a number. It's approaching 0. So that's the visual difference between diverges and converges. We're going to take a look at sequences and determine if they converge or diverge, and if they do converge, we're going to be specific and give the limit. Let's take a look at these examples. Determine where the sequence converges or diverges. If it converges, give the limit. So let's look at A. So we are asked to find the limit as x approaches infinity of the function 1 over n. 1, 1/2, 1/3, 1/4, where is that approaching? It's going to be converging to a limit of 0. It's getting very, very small and approaching 0. Let's look at the next one. 2, 3/2, 4/3, 5/4. So why don't you take a moment right now to determine what the sequence is. So notice for question B, a sub n is equal to n plus 1 over n. So I'm adding 1 to the numerator and keeping the denominator the same. So as a limit of n approaches infinity, n plus 1 over n, I could break that down to n over n plus 1 over n. N over n is 1 plus 1 over n. So let's think about this logically. I have my constant 1, and if I substitute numbers all the way to infinity in for n, it's going to converge to 0. But here I'm going to have 1 plus 0, which ends me with 1. So this sequence is going to converge to 1. Now, if we look back here, because I'm going to infinity, we can also look at the degrees. The degrees are the same, which means the ratio of the coefficients gives us our limit. 1 over 1 is actually 1 as well. So that's another way to look at it. Let's look at C. So let's find the sequence of C. 2 times n. So I really want to find the limit as n approaches infinity of 2n. If I substitute values 1, 2, 3, 4, 5, and so on all the way to infinity, the sequence is going to go to infinity, which means the sequence diverges. And finally, let's look at D, -1, 1, -1, 1. which is really negative 1 to the n. This oscillates forever between these two values and therefore has no limit. So therefore, the sequence diverges. So there's a think about it question at the bottom. Do arithmetic sequences converge or diverge? So take a couple moments, pause the video to think about, do arithmetic sequences converge or diverge? So only when d is equal to 0 and you stay constant does the arithmetic sequence converge. Otherwise, you can go up forever or decrease forever, which means it diverges. If you turn to the next page, what about geometric sequences? Find the common ratio and then determine if the following geometric sequences converge or diverge. If it converges, find the limits. So take a few moments right now to pause the video and figure out what the R value is and if it in fact converges or diverges. So let's take a look. For A, 8, 4, 2, 1, 1/2. My R is 1/2, I multiply by 1/2, and if I continue this process, I'm going to converge to 0. For B, 1,000, 100, 10, 1, my R value is 1/10, I multiply by 1/10 to get the next number in my sequence, but this is going to continue to converge to 0. 50, negative 25, 12.5, negative 6.26. Multiplying by negative 1/2, and again, if I continue to do this, I'm going to converge to 0. Let's look at D. My R value is 3. I multiply by 3. 1, 3, 9, 27. This is going to go all the way to infinity, so it diverges to infinity. E, 0.01, 0.1, 1, 10. I'm multiplying by 10, and again, I'm going to infinity, so I diverge. Negative 2, 4, negative 8, 16. I'm multiplying by negative 2, and again, this goes on for forever to infinity, so therefore I diverge to infinity. So finally, a geometric sequence converges if negative 1 is less than or equal to R, which is less than or equal to 1, given by examples A through C. On the next page, we have our practice problems. Determine whether the sequence converges or diverges. If it converges, give the limit. So again, take a look at these example problems, 1 through 10. Pause the video to answer them and tell us if they converge or diverge. And if it does converge, what is the limit it converges to? Please pause the video now. Let's take a look at the answers. Number 1, 3n over n plus 1. The limit as x approaches infinity. Remember, the degrees are the same, so take the ratio of the coefficients. So that's 3 over 1, so therefore it converges to the limit of 3. Let's look at number 2. The limit as n approaches infinity of 5n squared over n cubed plus 1. It is bottom heavy, so therefore it converges to 0. Number 3, the limit as n approaches infinity of n cubed plus 2 over n squared plus 2. It's top heavy, so therefore it approaches infinity. If it approaches infinity, the limit does not exist, so therefore the sequence diverges. And number 4, I have a sequence, 1, 4, 9, 16, all the way to n squared. The limit as n approaches infinity of n squared goes to infinity. It keeps getting bigger and bigger. Therefore, the limit does not exist, and the sequence diverges. Let's look at the next page, number 5, 1, 1/4, 1/9, 1/16. Again, it's getting very small and converging to 0. Number 6, the limit as n approaches infinity of 3n minus 1 over 2 minus 3n. Again, the degrees of the numerator and the denominator are the same, so take the ratio of the coefficients. 3 divided by negative 3 is negative 1. Therefore, it converges to negative 1. Number 7 converges to 2. The degree of the numerator and the denominator are the same. Number 8, 0.5 to the n, that resembles exponential decay, so it's converging to 0. I drew a little bit of a graph to show you as well. Number 9, that resembles exponential growth, so therefore the limit does not exist or goes to infinity, so therefore it diverges. And finally, for number 10, a sub 1 is equal to 1, and a sub n plus 1 is equal to a sub n plus 3. For n is greater than or equal to 1, this is recursive, so my arithmetic difference is 3, and I keep going plus 3 all the way to infinity, so therefore it's going to diverge. I hope that was helpful. If you have any questions, please message me on Teams. Thanks so much. Have a great day.